Hello again, and welcome to Practice 50. This one is about polygons. It's on page 62 of your workbook. Number 1. A line drawing of the Washington Monument has a long rectangle topped by a triangle with two equal sides. So what type of triangle is it? The Washington Monument in Washington, D.C. is called an obelisk. It has a special name. It's a long, tall rectangle, and on top of that rectangle is a triangle that has two equal sides. So we'll say that these two sides are equal. The question is asking me to focus on the triangle. We're not worried about the rectangle. We're just looking at our triangle here. A triangle with two equal sides is isosceles. The entire monument is called an obelisk. Let me give you that word. And that is just the name of this whole shape. So an obelisk is this shape. But we are just looking at the triangle itself for this question. Okay, number 2. Which shape is not a parallelogram? Parallelograms have two sets of parallel sides. So there's one set. There's a set. This is a parallelogram. Its specific name is a rhombus. This one has one set, two sets. That looks like a square to me. A rectangle has one set, two sets. There's one set. Here's the second. But look at this guy. This is a trapezoid. We have the one set, but those two sides right there on the left and right, those would eventually touch. They would eventually become a triangle. So this is not a parallelogram. It's a trapezoid. So B is not a parallelogram. Number 3. The surface of a foundation of a house is a rectangle, which might not be an attribute of the rectangle. Now, attributes is characteristic or trait. So let's draw the foundation of the house. Something like that. Two pairs of parallel sides. There's a pair, and there's a pair. So A is true. B, 4 right angles. 1, 2, 3, 4. That's true. 4 equal sides or 4 sides? Well, we definitely have 4 sides. We have this one and this one are equal. And then this one and this one. Let me mark those. I need to show you how to mark that. Those tick marks show you equal sides. So the yellow are equal and the blue are equal. But they're all not equal. So C is the one that is not an attribute of this particular rectangle. You have 2 long sides and 2 wide sides. Which statement is not true about an obtuse triangle? Well, let's draw ourselves an obtuse triangle. You need that obtuse angle. And then there's the third side. It's one of those long, skinny triangles. It has one angle greater than 90. That's true. If it's obtuse, it has to have greater than 90. It has 2 angles less than 90. That's true. Look at these little bitty angles over here. Those will be there. Those tiny little angles are part of that obtuse triangle. It has one angle equal to 90. That is not true because it has that obtuse angle. And it has 3 angles. That is true of any triangle. So the one that is not true is C. There is no right angle in this kind of triangle. Number 5. Which 3 polygons are subsets of parallelograms? Now remember what parallelogram means. A parallelogram must have 2 sets of parallel lines. It is a 4-sided shape because it has 2 sets of parallel lines, and 2 times 2 is 4. A circle. Is that a parallelogram? No. A square. That could be. That's 4-sided. A triangle. That's 3-sided. So it's not a circle. It is not a triangle. A rhombus. Remember, that's the square that's leaning, and I can't draw it very well. Let me try that again. Let me draw it large, and then I can make it smaller. I can't control my pencil when it's that small. That's still not what I'm looking for. Let's make him, there we go. Something like that. It still is not precise, but that's about as good as I'm going to get it. Let me make it smaller. So there's the rhombus. A trapezoid. Now be careful with trapezoid. Remember, I told you it's a triangle that got caught in a trap. So you have this line and this line that are parallel, but then these leaning lines would not be parallel. Eventually, those will touch each other. So we don't want to call that parallel. And I'm going to mark them for you. Let me just make that smaller. And then a rectangle, of course, you know what that is. That's not it. There we go. So let's check the 2 sets of parallel lines. In this one, I have the blues, and then I have the yellows. So that one is one of them. That's 2 sets. Here I have the yellows, and I have the blues. In this one, we have the 1 set of parallel lines. And then in this one, we have 2 sets of parallel lines. So for it to be a parallelogram, it has to have 2 sets. So the trapezoid is out. I would go with B, D, and F. B, D, and F. Number 6, yes. Are all squares rhombuses? Are all squares rhombuses? And remember the definition of squares. Squares have 4 equal sides and 2 pairs of parallel lines. So yes, squares are parallelograms with 4 equal sides. Number 7. Which statement is true about rhombuses? Which statement is true about rhombuses? They are a subset of squares. They are a subset of trapezoids. They are a subset of rectangles. They are a subset of parallelograms. leaning squares. Number 8. Which shape is an equilateral triangle? Remember, those tick marks are showing me equality. This one has 2 equal sides. So this is isosceles. This is equilateral. This is scalene. There are no equal sides. And this is also scalene because there are no equal sides. B is an equilateral. Number 9. Which 2 answers are not attributes of all trapezoids? Let me draw you a trapezoid. This is one example of a trapezoid. It has exactly 1 pair of parallel sides. That is true. It has at least 1 angle that is less than 90. That is true. Right there's 1, and right there's 1. 2 pairs of parallel sides? No, not if it's a trapezoid. It only has 1 pair. 2 equal sides? We have this one, and we have this one. But that is not always the case. You don't have to have those being equal. In my example, they're equal, but they won't always be equal. And this says of all trapezoids. Let me draw you one where they're not equal. Look at this one. Because in my example there, they are. But don't be misled by that, because you could have a trapezoid that looks like this. Oh, I messed him up again, didn't I? Look at this one. We do have the 2 parallel lines. That's still the same. But look at these 2 sides. This side and this side are not the same. And that is still a trapezoid. So we don't always have equal sides. There will always be 4 angles, and there will always be 4 sides. But the 2 that are not true of all trapezoids for number 9 are C and D. Number 10. Polly draws a square. Which statement is not true about the square? It has 1 angle greater than 90. No. It has 2 pairs of parallel sides. That's a yes, and there they are. It has 4 equal sides. Yes, if it's a square, it has 4 equal sides. And it has 4 angles. Yes. It does not have an angle greater than 90. Number 11. Peter has a triangle design on his wall, which could not both be attributes of the triangle: equilateral and acute. Let me show you one of those. Whoa, that's horrible. Let me draw it large and then I'll shrink it. 60 degrees, 60 degrees, 60 degrees. That's equilateral, and they're all acute. So we're going to count that one. That can be, both of those can be true. Obtuse and scalene. Obtuse. Sorry, computer thought I wanted to draw an arc. Obtuse and scalene. That's true. None of those sides are the same. So that one absolutely can be real. Obtuse and scalene. Obtuse and right. That can't be, because obtuse means more than 90. And right means 90. So you can't have both of those. It's either one or the other. So that's the one that cannot be the same. You can't have an obtuse and a 90 degrees in the same triangle. Right and isosceles, that absolutely can happen. Here's an example. There's the right angle, and there's the hypotenuse. And these two sides are the same, so that is isosceles. It has a right angle and an isosceles description. So that one can be. Here's another reason on C. A triangle cannot exceed 180 degrees. So if obtuse is more than 90 and right is 90, 90 plus 90 is 180. So you can't go more than that. You can't have obtuse and right in the same triangle. Number 12. Are all rectangles also trapezoids? Are all rectangles also trapezoids? So let's look at those. Here's a rectangle. And here's a trapezoid. So yes or no? Are all rectangles also trapezoids? No, they're not. So it's either because trapezoids have more than 4 right angles, or because trapezoids have exactly one pair of parallel sides. That's the one you want. The one pair of parallel sides. But a rectangle, by definition, has a second pair of parallel sides. So they're not the same, because your trapezoids just have that one set of parallel sides. Number 13. Erilyn walks 3 feet east. That's this way. So east. 4 feet north. Let me try that again, because I didn't leave myself enough room. 3 feet east. 4 feet north. And 5 feet southwest to go straight back where she started. Which type of triangle does Erilyn's walking path form? Well, this is a triangle with 3 sides that are not equal. So they are part of a scalene triangle. No 2 sides are equal. Number 14. Which is not an attribute of a square? It is made of horizontal and vertical lines. That's true. It has 2 pairs of parallel sides. There's 1. There's 2. That's true. It has 4 equal angles. That's true. So I'm not sure. I may have to check on this one, guys. I'm missing something here. It has 4 equal sides. That's true. So which of them is not an attribute? Let me look at the answer set. A square rotated at an angle would not be made. Ah, okay. I missed this one. Here's the answer, and let me show you why. I'm not sure I agree with this one, but we'll go with what they say. And here's why they say this is true. If you rotate this square, hopefully I can rotate it, yes, to an angle, I guess I do agree with this. So I rotate that square so that it is on point. It is not horizontal and vertical. I'm not sure I like this question. I would argue with this one, but that's okay. It doesn't matter what I think. The person who wrote the book says that A is false, so we'll go with that. Because they say, and here's their explanation, a square rotated at an angle would not be made of horizontal and vertical lines. So maybe I would have liked this better if they said which is not an attribute of all squares. But I still would not like that. I just don't like this question. But that's okay. Number 15. Janelle says that all squares are rectangles. Byron says that all rectangles are squares. Who is correct? Janelle says all squares are rectangles. Byron says that all rectangles are squares. Who is correct? This is a tricky one. You really have to think through it. But the answer is B. Janelle is right because squares are a subset of rectangles. Remember, the definition of a rectangle is that you have two sets of parallel lines and 4 right angles. 2 sets of parallel lines and 4 right angles. Let me try that again. I'll draw it as one whole shape. 2 sets of parallel lines so we have 1, 2, and we have 1, 2. So there are the 2 sets of parallel lines, and that you have 4 right angles. The definition of a rectangle says nothing about the length of your sides. So let's apply that same definition to a square and see if we get a match here. Pretend that's a square. It is incredibly hard for me to judge length here. Now on this one, we have this set and we have this set. Here we have sides that are all the same length, but we still have the 2 sets of parallel lines. And we still have the right angles. So Janelle is correct. The square is a subset of the rectangle definition. Number 16. Which shape is not an isosceles triangle? Isosceles means 2 equal sides. So in this one I have this side and this side. Here I have this side and this side. Here I have this side and this side. And in this one there is no equality. This is scaling. So C is the one. That is not isosceles. Isosceles means 2 equal sides. Number 17. Stephen connects a rope to the top of a flagpole that is perpendicular to the ground and walks a certain distance away from the flagpole. What type of triangle does the pole, the rope, and the ground form? And here's the key word. but you know I'm going to draw this. So here's the flagpole, and Stephen puts a rope up here at the top. Okay, so the rope is hanging down here. Maybe Stephen is right here. And here's the ground. So here's the pole that is perpendicular to the ground. Here's the rope that's stretched down there, and here's the ground. What type of triangle? If it's perpendicular, it's a right triangle. Number 18. All trapezoids are also which shape? So let's draw a couple of trapezoids. This is the one I think of when I think of trapezoid. But remember that a trapezoid can look like this as well. It's a shape that's been caught in a trap. Part of it's lopped off. Are those squares? No. Are those rhombuses? Or rhombi is how I learned the plural of that. They are not rhombuses. Quadrilaterals, that means that they have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. They are all quads. They have 4 sides. Just like all the triangles have 3 sides, all the quadrilaterals have 4 sides. Number 19. Ronald draws a shape that has 2 right angles, 1 obtuse angle, and 1 acute angle. Which could be the shape? Now, this is a tricky one. Have to really think through it. Ronald draws a shape that has 2 right angles, 1 obtuse angle, and 1 acute angle. That's 4 angles. So the shape can have 4 sides. That eliminates a triangle. Triangles just have 3 sides. So even if you had to guess at this one, eliminate the triangle. Now, here's the clue. 2 right angles. That eliminates the parallelogram because the parallelogram is leaning. It doesn't have right angles. A rectangle has 4 right angles. So that can't be the rectangle. They're also equal angles. It's a trapezoid. And let me see if I can draw it for you. Actually, I did draw it right here. So let me not do that again. Let me just copy that one. And I'll show you what it's talking about. So here are the 2 right angles. That's 90 degrees and that's 90 degrees. Here is the obtuse angle. That's more than 90 degrees. And there is the acute angle. And there's your trapezoid. So number 19 is B. Number 20. Which statement must be true about scalene triangles? You know this one if you've been studying your flashcards. Scalene means 3 sides of different lengths. If you know that, pick that. The others may or may not be true, but this one is definitely true. They have 3 sides of different lengths. Okay, that brings us to the end of practice 50. Practice 51, I believe, is the last practice, and then we have a review. So I will see you soon for that one. and I hope you have a really good day. Bye-bye.